Yeah, I'm Ito. I'm a founder of Edison.watch. We do a lot of data leakage prevention software for MCPs, but also any agentic tool calls that transfer data from one location to another. Today, I just want to talk about the lethal trifecta and sort of all of the vulnerabilities introduced by MCPs. The lethal trifecta is a framework introduced by Simon Willison, which basically describes the specific preconditions required for your data to get leaked. So the lethal trifecta describes when an agent calls 3 types of tools all in one session, right? That can lead to a data leak. So the specific conditions are exposure to untrusted content, i.e., it has a chance to get jailbroken by some malicious attacker. Then access to private data, where it can go look through your private data like emails, API keys, or other sensitive documents. And then an ability to externally communicate. So this could be like send an email, or it could even be like write some document that is publicly visible. There's lots of different nuances around external communication, even ones around sort of GitHub comments and such. Let me show you a very specific example of this that is pretty scary. So I'll quickly show this setup where of how we can leak. Sorry, this is the victim inbox email. So in here, we have the victim email inbox. It has some sensitive data. Let's call it, some company financials or whatever. And then what the attacker can do to compromise this victim who has their email connected to MCPs and some agent. Today I'm using 𝘂𝘶, but this works with any Claude Code, ChatGPT, any other MCP clients. And we'll show how the attacker can send essentially 2 calendar invites. This could be 1, but it's way more reliable with 2 calendar invites that contains jailbreak prompts, right? Like this. And just by the victim, right, asking the agent to help plan their day, we can show how this would lead to a data leak. So let's run this through. This 𝘂𝘶 agent using Claude 4.5 Sonnet is connected to my email and calendar. I will say something like, yeah, help me plan my day. As a victim, that seems pretty benign, right? Like you wouldn't expect your data to get exfiltrated. And it goes like, yeah, great, I can see your calendar, blah, blah, blah. There's nothing too suspicious here. And then it goes like, would you like me to help you prepare for these meetings? Looks pretty legit. So you go like, yes. But what's actually happening here is when you say, help me plan for my day, and it looks through your calendar, it actually gets jailbroken because it reads these like jailbreak containing calendars. And the key thing to note here is that the victim doesn't even have to accept the calendar invite, right? So if you look here, like in the victim calendar, they haven't even accepted the calendar invites, right? Like they only need to be there. So all you really need is the victim's email for the attacker to carry out this attack. And then you can see here, now that it sort of read the jailbreak invites, it's now under the full control of the attacker. And then what it does afterwards is it will go read through all of your private emails, right? So now it has access. Now the agent has all of this financial information in its context window. And then finally, it forces the agent to try and go send this to the actual attacker. In this case, the attacker is just me. And if we just run this, in a second, we should get an email from the victim where all the financial information is blocked. And then, okay, oh, yeah, there we go. Yeah, you can see here, the victim has essentially sent all of the important financial information and all the data is exfiltrated. And, all of this happened with basically the victim not really knowing what happened, especially if they're non-technical, right? And the specific lethal trifecta here is, the exposure to untrusted content happened from the calendar invites containing the malicious jailbreak prompt. Access to private data is the inbox information, in particular the one that's containing sensitive financial information. And then the ability to externally communicate is basically just the email sending. But there's also multiple different variants of this where, for example, you can have a jailbroken GitHub issue, and then you can comment out API keys, and it accesses the local .m files and exfiltrates all of that. So there's lots of different types of attacks, but really they all sort of fit very nicely under this lethal trifecta framework. Of course, it's slightly different for stuff like, go destroy the database or something like that, but those will not be in the scope today. Okay, so this is clearly a problem. How do we solve this? So to solve this problem, we've created a open source repo, which is, I guess, like we call it an agentic firewall, where essentially we can block all of this lethal trifecta by actually looking at what enters the context window at any given point. So let me give you an example, right? Open Edison is this unified MCP gateway where we actually track sessions of agentic runs and then see, okay, was there, actually, let me go back to this. Okay, did the agent access some untrusted content? Did the agent access some private data? Did the agent try and go send external information, all of this information contained in the context window to an external attacker? And then we just automatically block anything that we deem dangerous, or whatever policy controls that you want in place. So let me actually run a demo of this, the exact same thing. Okay, we'll let that load up. But yeah, and then there's also a different variant of this where, this lethal trifecta framework can also lead to breakdowns of traditional role-based access control. So one example might be, okay, you ask the agent to go write some monthly company update email or something. It will read through Slack. Then when it reads through Slack, your context window is now filled with information that's internal to the company. But then when you get it to read a more private Slack channel, let's say with just the finance team, then now you actually infect the context window with some private knowledge that shouldn't be accessible to others. And this can break down RBACs because the agent doesn't really know what data should belong in what data buckets. So for all, depending on what happens, whether it's jailbroke or just by pure accident, all this data can get mixed up with different privilege escalations due to the agent sending the data across different buckets. I think now, oh yeah, there we go. So we can run the setup. And just with this very simple setup process, yes, we can actually secure our agent. Yeah, sorry. Oh, whoops, that is the wrong thing. Okay, so just with that setup, we should have, Open Edison loaded up. And now this is actually protecting all of the tools that we had earlier, all the calendar stuff. I've pre-configured sort of which tools are considered access to private data, untrusted data, and external communication. And then if we try again, then, okay, that didn't load all the tools for some reason. Okay, let me just revert to video because the live demo seems to have failed. But I guess, no, this is a different example. So if we run through, I guess, the exact same attack, right, that we had earlier of this calendar invite, but with ChatGPT instead connected, with Open Edison running in the background, what happens now when you run through the same attack is it will do the entire sort of look through the calendar, blah, blah, blah. And Open Edison is essentially tracking all of the tool calls and what is in the context, as well as the particular risk levels of what's in the context window. And then finally, when it tries to, send this email, and when you click send, Open Edison will actually, give it a second. Yeah, Open Edison will essentially determine that you reached the lethal trifecta by, looking through untrusted content, private emails, and try to externally communicate, and it will actually completely block that transaction until the user gives manual approval. And, in terms of the value prop that this can bring, you actually can make a much more nuanced decision around agentic tool calls of what's dangerous and what's not dangerous, instead of needing to approve every single action with a human in the loop, because that can lead to exhaustion. And we only warn you about very suspicious or risky tool calls. But that's mostly it from my end.
Thanks. I am, very interesting demo. So architecturally, I was a little bit confused about what you actually have here. So it's an open source project that runs locally that I install on my machine, that basically it works as like an MCP proxy or gateway or something between all of my MCPs and the clients. And then I add the Open Edison MCP to each of my different AI clients, and then it effectively proxies all the calls to the other MCP service. Am I picking it up architecturally? Is that effectively what's happening? It's a piece of software that sort of sits as a universal MCP and then and analyzes all the MCP calls that are happening?
Yeah, so we just read through like all the MCP, we read through MCP.json during setup, and then we just wrap around all the MCP tools that you have. And then, we auto generate using just LLMs of like, oh, this tool is, external communication. This tool can get access to untrusted content, right? You can obviously modify these config files on your own. And then, essentially, we're always looking at different agentic sessions that are happening using this Open Edison as the proxy, and we block anything that is dangerous. And we have a desktop app as well where you can get notifications of, hey, this is dangerous. Are you sure you want this to happen, right? And you can kind of let agents go on YOLO mode by default without worrying about something catastrophically bad going on.
Got it. And the software, it's a local piece of software that's open source that I install. And then when I add additional MCPs, like I want to add a new MCP, I go to the config of the Open Edison, and that's where I sort of add in a new MCP server. Is that kind of instead of adding it directly to, say, Claude Desktop, I would add it to the MCP JSON.
That's exactly right. And we have a configuration where you can always be constantly looking for like new MCP tools added, and then we just auto add it to Open Edison.
Got it. And the software, it is local software, so it's not a SaaS service.
It is local software. Yeah, it's local. It's open for anyone to use. We can have a hosted version if there is a demand for it, but it's really like light deterministic software, and so it's honestly better off just running it locally.
Do you bring your own LLM keys for the LLM element of it? Like, do I need to give you my my OpenAI keys or Claude keys, and then use the model inside there, or how's it using? You said use the model to do an analysis of the different MCPs as I add them over time.
Yeah, so for I should have mentioned that. Yeah, for the actual like auto config generation, that specific part is bring your own keys.
Got it. So and that's part of the config. I sort of set up my keys, I install them, and then when I add an MCP, it sort of analyzes it. Is it proxying every MCP call and reviewing the calls? Like, is there a filtering going on every call? Is that how it's like you're basically like I'm calling your MCP, and then inside your MCP, the logic is sort of reviewing the call against a set of known bad behaviors or against a set of heuristics? Like I'm still a little confused on what's happening inside. But it sounds cool.
Yeah, so there's a feature in MCPs where you can track what agentic session is happening, right? So session 1 could be like, oh, you just read the calendar, right? Then that's not dangerous at all. Session 2, a completely different chat session, could be like, oh, you read through some private emails and that's it. And then, if in a particular session you have the specific combination of like, let's say, read calendar invite, read private email, try to send, then we say, okay, that's a dangerous combo, right? So we take session by session context of like, I guess what gets context engineered, or we like to sort of use this analogy of like, if MCPs are USB sticks, we check when there is multiple USB sticks entered that can like cause this kind of data leakage problem, which is why the lethal trifecta is such a useful framework to think about these attacks in.
That makes sense. Do you is the proxy / monitor, like the layer of you called it kind of the MCP firewall, is that layer configurable though? If I wanted to change the logic in there and have it, for example, if I was a hospital and I wanted to look for PII going out to the models or something, can I write any filter in there, run any arbitrary checks, or is it kind of all dictated by the existing Edison framework?
Yeah, so we're actually working on a lot of the PII filtering, also like different types of data entering the context window as well, right? So is this code? Is this like PII? Is this, like sensitive financial data? And we want to be able to sort of have much more granular permissions around, in a condition where the context window or the memory is essentially polluted, right, with different information, then we really want tight controls around how the agent can like transfer information out of its context window.
Okay. Darren, any questions?
Oh, no, no, it looks pretty interesting. Don't really have any questions though, but yeah.
Very good. And in terms of the company, are you guys a startup? Where do you work?
Yeah, so we're a startup. We're mostly actually focused around, this kind of breakdowns of RBAC and like preventing data exfiltration. So one of the use cases that we're working with is the particular enterprise. It's like a 20,000 headcount enterprise, and they're just really interested in, adopting all agentic AI to unlock productivity and, different, just like better context management, but without any of the potential risks of, data exfiltration, essentially.
Very cool. Well, congratulations on the company. And this whole thing you showed today was open source. Is there a paid version that adds additional features or anything like that?
Yeah, so the paid version, the enterprise version essentially is just better, like, lots of different enterprise features like sort of firewall discovery or, integration into sort of single plane of panes like CrowdStrike monitors, or, a lot of the other like IDP integrations, right, with like Okta and SAML and what have you. But yeah, the actual sort of open source variant is what we use, honestly, in the production version. And that one is supposed to be for individuals who are, using MCP, since, quite a lot of the MCP usage right now is hobbyists. And so we just wanted an awesome repo that can protect individuals from data exfiltration risks.
Very cool. All right. Well, thank you so much for joining us, man. It was great seeing the product.
Yeah. Thank you.
Take care.